Okay, and this is the big picture. I want to talk about this coupling between the sun and the earth. As I said, the sun's atmosphere, the corona, is not in hydrostatic equilibrium. It expands. The solar corona consists of its plasma, hydrogen plasma. We have electrons, we have protons, we have some alpha particles. And the solar corona dynamically expands into space. In the distances beyond 10 solar radii, we basically have a supersonic flow of plasma moving away. We're talking about speeds of the order of anywhere between 400 kilometers per second to about 800 kilometers per second. So this solar wind is moving at supersonic speeds throughout the solar system. And it slows down and vanishes when you approach the boundaries, when you approach this region where the interplanetary medium interacts with the interstellar medium. And the region where the solar wind emanates is called, you form a shock, reverse shock, and it's called culmination shock. So throughout this 11 years of activity of the sun produces also, in addition to this steady flow of particles, there is also flares, where you have excessive amount of ultraviolet and X-ray radiation coming from the sun. And you also have so-called coronal mass ejections. These are large-scale eruptions of coronal material and magnetic flux that propagate through space. And they basically provide an additional disturbance that can affect us. And when these coronal mass ejections travel through space, some of them can move at speeds that are greater than the solar wind speed. So you, in a sense, you have shock waves that form during the passage of these coronal mass ejections. And we know from particle physics that these shock waves can accelerate particles, and mostly protons. And these particles, these protons, can reach ultra-relativistic speeds. They have very high energy of the order of 1 gigaelectron volt. And 1 gigaelectron volt particle can be very, very bad news for astronauts in outer space, or even for your satellites that are out there.